You're the first violin tonight. Ready. Aidan, you are muted. Number 13 and 3.4. Okay, can you give me the page number? It will help me with the page number only because I have the book here in the background. It doesn't matter which section I go to. I can put the page number in. Do you have the page number? Okay, 314. Perfect. 314. 314. Enter. Got it. Number 13, this one. So we have f of x equals 1 plus 6x minus 3x squared. We are given 0, 4, and we're asked find the absolute max and min. I will also ask you to identify the local as well. But yes, the absolute max and min values of each function over the indicated interval and indicate the x values at which they occur. Perfect. Awesome. So I get my table started right away, in which I have 0 to 4. That's nothing else. I will have to have f prime, and I will have to have f of x. Okay? Let me know if it's blurry, if you can't see, stop me at any point in time. So I have to study the first derivative. So I have to find the first derivative first. I get 6 minus 6x. The first function, the 1 prime is 0, 6x prime is 6, negative 3x squared prime is 6x. I have to find critical numbers now. As we know, critical numbers come from two sources. From f prime of x being 0 or from f prime of x being undefined. This is a polynomial function. There is no such thing for a polynomial function to be undefined at any point. So no critical numbers will come from this. But I have to solve this equation. And when I set this equal to 0, 6 minus 6x equals 0, I get x equals 1. If you move and subtract or divide or whatever you do, x equals 1. So x equals 1 fits between 1 and 4. I have to write 0 for the first derivative. And I have to study the sign of the first derivative to the left of 1 and to the right of 1. So I plug in 0. So it's positive. I plug in 4. It will be negative. At this point, I put this function in the graphing calculator. I'm going to share the screen in a moment. And find the function value at this point, at this point, at this point. So that was the first thing I'm going to do. So I'm going to share my screen, go to the calculator, in y equals. I put in the function I need. Let me just click on this and just turn it off. Okay, it's off. Okay, so in y equals, I clear and I put in this function, which is 1 plus 6x and minus 3x squared. And I go to second and table and I plug in those numbers quickly. 0, I don't need a calculator, but I wanted to show the whole steps. So I got 1, 4, and negative 23. 1, 4, and negative 23. I go back to my table. 1, 4, negative 23. At this point, I need to make sure that these two rows work well together. What does that mean? This is when I find discrepancies or potential mistakes. So from 1 to 4, the first derivative is positive. The function must increase. Yes, it does. From 1 to 4, indeed, it's increasing. When the first derivative is negative, the function has to decrease. Does it? Yes. From 4 to negative 23, it does. And now I make my conclusions. I realize that the function goes from, I'm not graphing the function, but it goes from 1, it goes up to 4, and then down to negative 23. from 1 up to 4 down to negative 23. So this is very clear that this point is nothing. 0, 1 is nothing, because at the end point of the interval, it cannot be a local. It can only be an absolute max or min. It cannot be absolute max because there is one higher than it. It cannot be absolute min because there is one lower than it. So obviously this is the absolute max and this is the absolute min. Since this is in the middle of the interval, it's also local max. That's the whole analysis for studying a function on a closed interval. Finding max, min, local max, local min. There is only one absolute max, of course, and there is a local max at this point as well. Which point? 1, x, y. 1, 4. Point 4, negative 23 is an absolute minimum. It cannot be local minimum because it's at the end point of the interval. Local or relative has to show that the function exists on both sides. Here I cannot show that the function exists on both. Of course it does, but I'm given this interval and I have to stick with it. Any questions on this one? Anyone? Any questions? Okay, next one. Can I see a quick example of when it's undefined? Yes. Yes. So is it just where it is below 0? No. No. So for example, perfect question. So if I have f of x equals the square root of x, this function, you have to remember this, has to have this domain. This quantity, the quantity under the square root, has to be greater than or equal to 0. So the domain of this function is 0 to infinity. But when you determine f prime of x, you get 1 over 2 the square root of x. And if you want to determine critical numbers come from f prime of x being 0, none. How come? A fraction is 0 when the numerator is 0, but the numerator cannot be 0, it's 1. And critical numbers come from f prime of x being undefined, where the function exists, right? Because if this is undefined, where the function doesn't exist, who cares? There is no max min there. Okay, but here notice that yes, this exists. There is a value of x where the function, I just want to make sure that I'm positioned correctly with the other camera. So yes, x cannot be 0. So at x equals 0, this function exists, but this function does not. So this is a critical number. X equals 0 is a critical number. Coming not from f prime of x being 0, but coming from f prime of x being undefined, where the function is defined. F of 0 is 0. But the function does not have a derivative. The derivative does not exist at 0. And that's a critical number. And it happens to be the absolute minimum as well for this function. Okay, very good. Other questions? Anything else? That's it? We don't have anything else?
Miss,
Yes.
is it possible to go over page 290, question number 4? I'm curious.
You said page, which page? I'm sorry, I didn't catch that.
290.
290 you said?
Yep, it's 3.2, question 4.
Yes, so let's take a look. Is it part of the homework or?
It is a part of the written homework. My biggest question is how I should, like, I have the answers and stuff. I just want to make sure I'm putting it in the right form.
290.
Again, it is a part of the written homework.
Okay, we'll look at problem 3. No problem.
So my question really,
So identify the points of inflection and the intervals where the function is concave up or concave down. Perfect. Okay, so I'm going to look at this one, number 1. Holds water, holds water, holds water, holds water. Ah, does not hold water, does not hold water, does not hold water. So obviously the inflection point is 1, 2. So I will write IP 1, 2, and the inflection and the intervals will be concave upward between negative infinity and 1. So concave upward, negative infinity and 1. Concave downward between 1 and infinity.
And we don't use brackets, right? They're parentheses.
No
Even
brackets
though we
ever.
like-
No brackets.
And what about if there's?
Let me
is it
explain
possible-
why. Let me explain no brackets. See, if I close this here,
Mhm.
I'm telling you that the function is concave up at one particular point. The function cannot be concave up at any particular point. It can only be on an open interval.
Got it. Part of my question also with this is, what if I had 2 parts of a graph that either concaved up or concave down? Do you
Right,
use
so
a
I will write
union
negative
or
infinity
just
1 union 2 to 3.
union? Got it.
And I will write, I don't know, 3 to 4, union 10 to infinity.
Got it. That helps me. I just wanted to make sure if we use a union or comma there, so that helps me a bunch. Thank you.
Yes, we use the union.
Okay.
So I see in 3.6 question 3 on page 341. Very good. Let me share my screen. And you said page 341. Okay, and we're looking at problem 3. Let me copy it. Problem 3, we have f of x equals x plus x squared, x equals 3, delta x is 0.04. And we're asked to find delta y and dy. Awesome. Okay. So here there are 2 concepts. Delta y is exact. dy is approximate of the delta y. So delta y is approximately, I meant to write dy. Let me erase that. Then I'll write the formula in a second. I need this to be neat because I want to post it for you. So that's why I'll post the PDF file. Okay. So the exact, the formula is f of x plus delta x minus f of x. dy is a very nice and easy formula. It's f prime of x dx. This is complicated. This is easy. When I find f prime of x, I get 1 plus 2x. So this is, as I said, easy. 1 plus 2x times dx. So all I have to do for dy is just a line. I replace, this is also the same with dx. I replace this piece by 0.04. I replace this piece by 3, and I'm done. 2 times 3 is 6. 6 plus 1 is 7. So I have to multiply 7 by 0.04. And I know everyone knows how to multiply this, 0.28. And this is done. This one requires more work. Why? Because I have to determine f of delta x plus x, which is f of 3.04, and subtract f of 3. Plug this in the calculator, plus this in the calculator, and subtract them. That's all you need to do. Is this okay? Is that a yes? Is that a no?
Actually, hold on. I'm just taking a second to analyze it to make sure I can understand it myself.
Of course.
So 0.28 has not 3.0. I'm trying to figure out 3.04 just came from just by literally adding.
But that's what it says.
Yeah, no, I just saw function of, but you're just saying just add the x to the d of x and that.
But this is what it says, f of a f of a quantity. You have to find the quantity first and then apply f to it. That's the rule, right?
Got it. Yep. So
Perfect.
Plug it in and then subtract it. Okay. Awesome. Yep, that makes sense. And we could find. Did you end up finding that answer, or did you just leave it as that?
No, I want you to plug it in. I want you to plug in 3.04, find a number. I want you to plug in 3 in f and find a number and subtract these two. If you want me to subtract and do the algebra, I can.
No worries, no worries. I see that now.
Yeah. I can do that. I'm writing to one of your colleagues to please join the Zoom now. She was asking the question. Okay. I just sent it. Yes, next question. Do you need me to plug this in? I mean, there is no problem. I can plug it in.
I guess my question what the purpose of doing the dy there, because I don't see that you plug that back into the delta of y, right? Like you don't plug that back into that.
These are two different things. This is one thing, and this is the other.
So I guess my question was, are you just showing us both?
The problem was asking us to find this and to find this. That's all we were asked to find.
Got it. Sorry.
No, that's okay. You may have not gotten that far, so that's fine.
No, I'm actually doing problem 4 right now, so it was great that she asked that, so I could follow along.
So when you will plug it in, you have 3.04, and you have 3, and all you have to do is subtract 12.282 and subtract 12. So the answer here is 0.282. As expected, they have to be very close.
Yep, that makes sense. Awesome. Thank you very much.
Thank you. Yes. So one of them is the exact, and that's always more difficult to calculate because first of all, I have to add 3 to 0.04 and then plug it in and then have to subtract when I plug in 3 in the function. So it's just all here. There is only one line. All is very easy. Two times 3 is 6, plus 1 is 7. 2 times 3 is 6, plus 1 is 7. Is this okay? So Isra, please say something. Is this okay now? You asked about the 7.
Yeah, I see where you got the 7 from now. On that third to last line though, where you have f of x plus the delta x minus fx equals, that part is kind of like a little small for me. Could you explain what you have written there? The f of 3.04 and
3 plus delta x. 3 plus delta x. Oh, you have to pin the speaker. Please, so go to the view and pin the speaker, and you're going to see this on the entire screen. Do you know how to pin the speaker?
I'm trying to figure it out right now.
And you will see this on the entire screen. Yes, I saw 23 on 350.
If you double click on the person's picture, you can bring it to the front as well.
Don't forget, I'm posting this after we finish.